from you guys. Yes, sir.
31.46%.
Say again?
31.46%.
31.46%. Did anyone do the mint? Anybody? Very good. Mary, what value did you get?
59.76%.
Oh, now see, isn't that interesting? Okay. Now can we take a look at our data table? And let's see, I think we are all with at least one other team member that we can compare our data table to. So could I ask you to just take 30 seconds and do you mind comparing, and you didn't have to do a table. I'm so sorry that I said that. Compare your data presentation that you have with how your other partner conveyed it. And can you make the choice of whose is better? Go, 30 seconds.
Oh, you didn't subtract. Yeah, that's not so well. You have to subtract.
Okay, can I interrupt us, please? Okay, just please halt. All right, now I asked us to compare the data presentation. The first thing I heard is, what number did you get? What did you get? Wait, did I ask you to choose the better? How do we know what is the target? Do we? Like, oh, well, that's really low. How do we not? How do we know? This might be spot on. This might be spot on. They both could be way far off. That's not what I'm asking. That's not what I'm asking. Now, what I'm also hearing, though, is in discussing with your lab partner, maybe we're finding that we made an error. A lot of us did chew our gum to get the sugar out, which was a great option, But did you then get the value you needed to find the percent sugar? Or did you find the value of the percent everything but the sugar? This was what I was asking. Okay, and then you can resume in another 20 seconds. Who amongst your team members presents the data the best? Not the best data. How do we judge that right now? We don't know what the target is. Who presents the data the best? Go.
You just subtracted your thing or 100 by that thing.
And then I divide the amount of sugar by the amount of the first part that in general that being juice, and then I divide it by. I know we did. Hold on.
I'm not invested in things.
I'm not.
Okay. All right.
Yes.
If I can just repeat that. Oh, so this is the prime example.
Yeah.
Okay, now what you said is, can we read it? Oh, golly, that would just be required. And so I hope all of ours are neat enough. So is it okay if I put this on the document camera? Okay. Are you sure? I haven't looked at it. Are you sure? Okay. So we will see.
You can read it.
Yeah. Oh, I think it's fun enough. Definitely. Okay. When data is presented, can you, upon initial look, tell it's collected data from an experiment? Is the data easy to read and interpret. Okay, so what kind of would not be good is if we just had a bunch of numbers. We say, okay, we're done. Well, okay. What is going on with those? Those mean nothing without units. So when you look at your data, does everything have a unit? That should. Okay, phenomenal. Even more than that, then, have you indicated what the data represents? Anthony, man, well, orange will have to do. Like, look, you didn't just say 8.401 grams. You said 8.401 grams is the gum and the wrapper. Then you said, well, that's the wrapper. So this is just the gum. That's the gum after being chewed, and then what the data is. Great. 2 thumbs up. Excellent, excellent. Okay. Sir, what the heck is this? Wait. Mass, dude. So we want to make sure we have correct terminology. Okay. Now we absolutely should show our work for any calculations. And sir, I love so much that you actually like have the equation and then your numbers in the equation with units. Star and smiley face times 100. Oh, so we'd say that is the percent of sugar. Okay. Good. Would someone else feel okay if thank you. I really, really appreciate that. Okay. Can I point out what I really like in Luke's? I like that you underlined. For me, that helps that stand out to me. So personally, I really like that you underlined those. Could I have another example? Would another group feel okay? Now, sometimes spacing, isn't just nice that it's not all crammed together. So very, very nice. Oh, you don't want you to feel star denied. Really, really good job. I love that you had the equation and so on. Oh, and you even went like, oh, so you know, further. Oh, wait. So the parts dissolved, but is that the mass? Wait.
I didn't want to say just sugar in case there was flavoring.
Oh, so you just like protected with your language. Oh my gosh. Listen. Oh, I'm going to give you star eyes. Yay. Big smile. That is excellent. That's really good. I'm sorry that it took me a couple of minutes to, sorry about that. Anyone else feel okay?
My second one is good, but I can do mine.
Would you mind?
Yes.
As long as you feel comfortable. And please know I'm not going to make a frowny face unless it really is deserved. So I'm sure Raven, no. You're good?
Yeah.
Can I?
Yeah.
Oh, very good.
I drew a frowny face.
No! Oh my gosh, no! Oh, well, okay, this is fine, like gum in grams. A better, that's okay, I wouldn't, well, I am gonna correct it just because we're talking about this together. How about the mass of the gum? And it's in grams there, yeah. So, that probably would be the only thing. And then we're missing, how did that become that? Now I know we multiply by 100, but we should show that. And then, oh, we definitely want to show units, Did anyone think of a table? That's if I would have asked for 2 trials. So this is, oh shoot, I should just pull this out of here. I'm sorry. It's reflecting. So this is just something I sketched really, really quickly. But a table, not required, but just like the underlying, often a table just draws your eye and visually organizes what you're conveying. Thank all of you so much for feeling comfortable sharing. Can I please collect your data tables? It's just going to be evaluated for like a participation. And as long as that you've given effort toward it, you're good. Data tables include all measurements, but that's not the only thing. Data tables include measurements, calculated values, and theoretical values. Tyler, what did I just say, sir?
You're calculating the mass of a theoretical value.
What?
There's something about theoretical value.
Okay, I'm going to say it again and ask you to repeat it twice.
Okay.
Okay. All right, sir. A data table contains all measured values, calculated values, and any theoretical values. Go.
Calculate, measure, theoretical, or I'll flip it.
There it is. Begins with a C.
Calculate.
Yes. Today's data table, I'm just going to get, okay, we are going to be collecting masses. We're going to be calculating values and be relying on theoretical. Okay. I should never see a number in a calculation that I've not seen in the data table first. And calculations, I appreciate and respect creativity, individual creativity, absolutely. But we need to obey a certain order. And please, you never have to put a table, but usually that's just preferred because that just helps to organize things. And the calculations always come after. So that is why we present the data and then the calculations. And if you think, ooh, I use that number here, but it's not first shown in the data, well, then we need to add it to the data. Go, sir. Like what? The only exception, sir, that you don't have to show me the work for would be an average atomic mass, which we just pulled from the periodic table, or a formula mass that like how many grams per mole there are in water. So you don't have to show me the work for that or put that in the data table, but otherwise. So if you can think of one, just let me know. Okay, like the 100, make something a percent. You don't have to show me, those are the only ones that I can think off the top of my head. But if you can think of any or want to ask about any, just let me know. All right. So. Absolutely. All right. So ladies and gentlemen, we are going to perform an experiment to experimentally determine the percent of oxygen in potassium chlorate. All right, Mary. Potassium chlorate. What formula would that be? Yep. Is that a balance? Do we need one potassium for every one chlorate?
We would need two
What is the charge of chlorate?
-1.
Yep. Charge of the potassium ion?
Oh, +1, so it is balanced.
You're right. Absolutely. Ionic compound. Remember, ionic compounds are held very strongly by electrostatic attraction, that positive and negative ion. Potassium chlorate, like ionic compounds, are solid at room temperature and pressure. Most ionic compounds are white, and that includes potassium chlorate. So you'll see in just a little bit, this is a white powdery solid. We are gonna heat this intensely. And the chemical equation conveys a lot of information. If you ever see a triangle open or colored in above the reaction arrow, that means heat was applied. We're performing a reaction. Even though the reaction is really not our focus, it's just a means to an end kind of thing. We are going to heat this so strongly that we will drive the oxygen off. We are making two products from this one reactant, oxygen gas and potassium chloride. Don't worry about these numbers. I just want to balance this equation for us. We'll learn how to do that very, very shortly. That's the reaction we're doing. And collecting information as we go will allow us to determine the percent of oxygen in the potassium chlorate. Okay, what I'm going to ask us to do now is ourselves, beginning with the safety information, can you read steps 1, 2, a safety information, but procedure 1, 2 continues on the back into 3. Okay, so can we take a couple minutes and read that, and then I'll ask you questions about what you read. Go right ahead, sir. If you don't mind signing out and taking a pass, that'd be appreciated. Thank you. Okay, good. Anyone need a little more time? Okay. All right. This lab is a very classic laboratory that will yield excellent results. And the majority of honors chemistry students throughout the country will at some point perform this lab. This lab involves a special type of container that we have not used yet. So what did you read? What will we use to do our heating in? Go. Excellent. Thank you, Sophia. A crucible. Are made of porcelain. We're going to choose a crucible whenever we need to intensely heat something. Crucibles are not in your lab drawers. So you guys will have to, one person from the group, choose a crucible and lid, which we can call cover. Any of these are good. They're clean. Some of them could be stained, but they're clean. So for example, this one's stained. So I'll just show us. All right. So that's an example of one that's stained, but it's clean. This is clean, but not stained, but both are fine. You want to choose a lid that is larger than the opening so that it does not snugly fit. So this, you can wiggle this back and forth a little, that would be okay. But here, that just kind of sits on top of that one. So no, this would not be good for that one. Where this lid, oh yeah, you can see that it is larger than the actual crucible. So there's room. If this expands, then the lid will not get trapped on it. That's why we want the lid to be larger. These crucibles are glazed, so they're slippery. We want to take a lot of care in handling them with tongs. So we do have these in our drawers. We're going to most times need to handle the lid and the base separately. So that's why this has this lip on the lid so that we can handle, the lid. Whenever you take the lid off, we always turn it over before we set it down. We're often doing reactions, and often species can collect on the top or the inside of the lid. So if we set the lid down, we're probably going to lose some of our substance on the table, on the ceramic fiber square. So we want to always put them down upside down. We can handle the crucible by the side, just like that, just like that. And then if we ever just are waiting for it to cool down, we always want to put the lid back on. Ceramic and porcelain can absorb water. And so we just want to discourage water vapor from collecting, and putting the lid on can do that, but also it prevents water from being directly absorbed or quickly absorbed by the substance that's in there. Your tongs do have an opening in the center here. Depending upon the crucible that you choose, it could be enough diameter that you could pick the crucible up by there. So you don't have to handle it this way if you feel more comfortable. But for example, this, I believe, yeah, see, that's not going to work with this one. So, if you get one like this and you'd rather have a crucible that you can support this way with your tongs, go ahead and get another one. The other thing that you will need, and I'm so sorry because in the morning class, again, they did not listen very well when I was talking to them about the procedure. So a lot of them made mistakes. They had to start over again. You should not have a pipe stem triangle in your drawer. So when you come and get a crucible and lid, also just get one of these crucible or pipe stem triangles. They may have gone back in your box. I'm so sorry if there is one, because of all the mishaps that happened in the morning. I didn't get to remind them to not put this in the boxes. Hopefully they remembered, but I didn't get a reminder to them. The pipe stem triangle will hold the crucible as you're heating it. So before you do anything, you need to make sure that whichever crucible you've chosen, that the pipe stem triangle allows the crucible to sit down in. Okay, so whenever you have it, you should be able to see the base of the crucible below the clay on here. If it doesn't, then we need to open up, and this wire will manipulate for you. If you need any help, just ask. If it's too broad, then you may need to push it inward, and this may break, and that's okay. That is okay. Just as long as it doesn't sit up on it, we want it to sit down in. So I probably would open this just a little bit. That's much better to let it sit in. Okay. All right. So that's the crucible and lid. Oh, some crud on there. All right. Next question. Oh, do you keep the lid on always when you're heating? We do multiple heatings. Do you always keep the lid on? Carter? Yes, you do. You're always going to keep the lid on while you're heating. When you take it off to cool down, then you'll take it down. Okay. You are doing multiple heatings. I want to make sure we're clear on it. The very first thing you do before a single measurement is you heat it. Yeah. And we know what we need for the heating setup. The ring stands, they're in the corners. You have a Bunsen burner striker, wire gauze, ceramic fiber square, iron ring in your drawers. We want to strongly heat the empty crucible and lid. Sorry, you know how clumsy I am. And that will clean it. I have already added oil from my hands. Ooh, Gerhardt cells. Ugh. Plus, it has water absorbed in the ceramic. So the first thing that you do, strongly heat. Double cone, you want the crucible base to be at the tip of the inner cone for 2 minutes. Whenever we're letting it cool down, we want to take it away from the heating setup. The ceramic fiber square or the wire gauze can be used. This is usually when the ceramic fiber square gets marked by the very high temperature crucible. So once you've heated it strongly, either turn off or just move your Bunsen burner away, then with your tongs. So after you do your first heating, you do not touch it with your hands. 1, you don't want to burn yourself. 2, we don't want to add any extra mass that we just removed. So I'm going to overturn my lid just like I did. Set that down and put the lid back on. We need to wait 1.5 minutes minimum, 1.5 to 2 minutes to let it cool down before we'll be able to accurately mass it. If it is too high in temperature, your balance will not read a constant mass. If it's too high in temperature, it'll be giving off so much heat to the surrounding air, it'll create air currents that will then cause your balance, which goes to the 1,000, to not settle. You know, whenever it runs, that mass runs, and it doesn't settle on a constant value. So if that happens, remove it, give it another minute, and then put it back. That'll be our first mass. So if you take a look at your data table, we do not put a mass here until you've done your strong heating, cool down. 2 minutes. Okay. Now, if we want to take a moment and just have a moment of silence out of just sadness for those chemistry students in this country that only have balances that go to the 100th place. So sad for them. The majority of chemistry students, that's what they use. So sad. That's why in your directions, you'll often be told, mass to the 100th, report to the 100th. Every time we see that, we just say, oh, that's for those poor individuals that only have balances that go to the 100th place. We have balances that go to the 1000th. Don't cheat your excellent balances. So these will be reported to the 1000th, yes? And I don't want to hear, but the direction said, because I'm telling us now. We write down everything the balance screen tells us. Okay, excellent. Then you add your potassium chlorate. Now, if you feel better carrying your evaporating, holy smokes, crucible over to your balance, or kind of pushing along your lab bench so that you're not allowing an opportunity for it to fall, you can definitely do that. But then we have, not funny, but I think I'm just like pleased with myself that I didn't drop it. Sorry that I chuckled. So let's say that I just got the mass of the heated, cleaned, empty crucible cover. All right. I'm going to remove the lid. And I know, imagine it's on the balance. Now I know that the mass is going to decrease because I've removed the lid. But then I am going to grab the container that's at each of the stations that has potassium chlorate. I have a scoopula at each station if you want to scoop in the potassium chlorate, and you're watching the balance screen until it increases about 2 grams. A little bit under, a little bit over is totally fine. This is a really powdery white solid. And whenever you're scooping it, it's really, really easy to lose some on the balance. So if you feel comfortable, while it's on the balance, you can just kind of give the bottle a tap, but keep a watch on the screen so you can see it change. Now, if I get really carried away and I put, okay, no, then we're gonna have to start all over again. The balance may be measuring this, but what we want is it inside of the crucible. Okay, obvious, I know, obvious. So a couple ways we can do that, but ultimately, now of course, pretend like there isn't any spilled, and if perchance it spills, just bring it to my attention and I'll help you like go from there and decide what to do. Put the lid back on and get what that mass is. Yeah? Okay, then we begin the long period of heating. Okay, Anthony, I applaud you so much, and I thank you so much for feeling comfortable offering up your data table for us to take a look at. Thank you. I really appreciate that greatly. Could I ask you, are there any questions or concerns that you had when you were reading about the steps to take to do the decomposition reaction? Anything there that's unclear? Do you remember where the oxygen intake, the gas intake, do we remember where those are? Or do you think we need a refresher? Mm-hmm. Where? Perfect. Perfect, perfect. So on our Bunsen burner, yeah, these are the oxygen windows. So when you're strongly heating, we want all the oxygen as possible to get to the natural gas for the double cone. But when we first start to heat, we're going to follow these directions, and it says close the oxygen intake. That will change your double cone to kind of a flimsier. We want to begin that decomposition reaction slowly. If we rush the decomposition, this will liquefy and then overboil and be a disastrous mess for us out of the crucible. So we want to just increase the temperature gently and then perform the decomp. So it talks about closing these halfway, or sorry, we begin with them closed, we open halfway and then all the way, changing the height of the crucible. Are we all good? If you have any concerns at any time that you think the Bunsen burner is too hot to touch, or this is too hot to manipulate, I wouldn't touch it there, but touching here, just ask. During this, does it say anywhere that you stop heating, you let your crucible cool, and you mass it? So 2, 2, 2, and 10, constant heating. Okay. Then you cool and mass the crucible and cover. Okay, so back to the data table. We're heating it strongly, getting that. Adding the potassium chlorate, getting this mass. Then we do the long period of heating. Let it cool, get this mass. Anthony, grand superstar today, what number would you like to choose between 10 and 20? Say again.
13.
Thank you. So let's say that Anthony's group, after that long period of heating, it cools and they mass it, and this is the mass. Okay, well then, not quite done. The process is called heating to constant mass. Heating to constant mass. Okay, Anthony, we are going, Aaron, sorry, Anthony, Aaron, we are going to reheat this for another 2 minutes and then cool, remass it. We are heating to constant mass. So ideally, sir, and of course everyone else, ideally, what value do we want our balance to read after that? Another minute or 2 of heating? Constant mass. If you reheat it for another 2 minutes and you get 9.500 grams, what does that tell you? Why? We are saying, Aaron, do you mind if I can ask you a little bit more? We are driving off the oxygen. Why do we use that terminology? Driving off. You know how lame my drawing is. I'm so sorry. This is what we start in our crucible and cover. That's supposed to be a crucible cover. And we do this long heating. And we are saying, Aaron, we are driving off the oxygen. Where is it going?
Into the air of the room.
You don't screw that lid on. It is not sealed. The oxygen, as it forms, it's going to escape. So, Luke, what will be left in the crucible when you do this mass? Oh my gosh, fantastic. What's the name of that? Chloride. Excellent. You've driven all the oxygen off. So if you have over a 10th change in mass, you need to heat it again. That's why I have these 3 lines there. You may have to heat again, and then hopefully that's just within a tenth. The majority of us will just have to do the 2 heatings. Don't worry, depending upon the time, if we get started in 2 minutes, we have plenty of time to do everything. Today, we are collecting our measurements. We are measuring 1, we are measuring 2, and we are measuring for 4. This is the calculated value. All the rest are calculated, okay? I want us to focus on getting these. If you would like, you can find this. Theoretical percent of oxygen in potassium chlorate. That would be like if I gave you that as a homework problem. Determine the percent of oxygen in potassium chlorate. That's our target. We didn't know the target for the bubble gum. And actually, it should be closer to 30% then, but you're not judged on that, on how close it is to that. But actually, at least from the label, our sugary gum is about 30% sucrose. So, I mean, you could calculate this today, but not expecting us to do any of this. Tomorrow we'll get with our lab partner to keep doing our work after we've collected this. Okay, the only other thing, I'm going to ask if there's any questions in a moment, but before that, so there's going to be some time, though it's just heated. We're not doing anything. We're not adjusting. We should keep an eye on our crucible, specifically looking for smoke. If there's smoke coming out from under the lid, take your heat away and then call me over and we'll make adjustments. We don't want that. So we don't want to not be looking at your crucible at all. Just keep an eye on it. But during these 10 minutes, you could possibly get your homework done. And your homework, I will ask us, page 15 from our packet. That's why I asked you to get your packet out. Page 15, this will give us practice going from name to formula. Okay? All right, so during the 10 minutes, if you want to do that, you can. This I will expect us to have done for tomorrow. Tomorrow, we'll pick up with our collected data and work through the calculations in our lab teams. Goggles are a must. Are there questions for me? If there's anything missing from your lab box, bring it to my attention. Okay, go team. Go right ahead, sir. If you don't mind, yeah, if you could sign out. Hello, students. So, I see your question, Abby. So, okay. The links that I'll reshare again. I also have the, just switch this out real quick so I can. So good to see you guys today. While your classmates are getting settled, I want to definitely address any of your questions. Okay. The 2 links I shared, one, I want to make sure that you guys don't feel like you're missing any understanding. And so I thought sharing the actual lab procedure, especially because I talked about it and then I asked your peers to read it before they went into lab. So that's what the first link is. I also have that in a tab in module 7 in Canvas. And the second link takes you to lab data. Now, it's totally your call, guys. Totally your call. And you guys can decide. It's the 4 of you. And so do you want today to work to try to make sense of these? Do you want to just wait until tomorrow and then I'll have you guys work as a lab team? Tomorrow, we're also going to, though, practice. We'll do this in the second part of tomorrow. I want to make sure that we have time to practice naming and formula writing. So tomorrow, we'll go over our homework first. So maybe if you want to stay here, you don't have to. But if you want to, and work through these and check in with each other. If you want, you can depart in a moment after I just make sure I've answered all of your questions. Do this on your own for tomorrow and wait on this until tomorrow. If you guys want, instead of waiting to do this until tomorrow, do you want to work together on this? So it's totally your call. After I check in to see if you guys have any questions, then you have my permission to go ahead and depart for today. Keeping in mind that Friday we will test formula and naming, and you can do that virtually if you would like, or wait till you're in person. As I said, you can tell me tomorrow what choice you'd like to make. But otherwise, this is definitely for tomorrow, and then you could do this now or wait till tomorrow. So it's your call. I'm going to address your peer questions and then come back. You don't have to stay, but I'll come back to see if you do have any questions I can address for you guys. Okay.